So let's start the session. I'll just share my screen first. So today we are going to do the crop recommendation using the random forest algorithm. I'll show you one project. Everyone can see this website. My screen is visible. You can type in the chat box. Okay. Okay, great. So now see, there is one project that is and the back end is that we have to perform the machine learning algorithm on it when we are having the data. And for the front end, what we have to do, we have done that the website has made so that it's convenient for the user to just check what would be the nitrogen, phosphorus if they are inputting some value and what the output they are getting. So because they don't understand machine learning, they don't understand what is it about. They just want a clear picture of what they want to enter and what is the output which they get. So this is the website, which is again made in the Python with the help of the Django framework, and you can see it's on the Heroku app, and it's an open source. So if you want to host your website, so you can host it online, and it's a free open source there. That is the Heroku app on which you can just host your website free, and they will give you the domain also. So you can just see over here ML Crop Consultant. So over here, you can see we have just made a beautiful website over here, and three things which we are doing over here is that these three services we are providing. All right, so first is the crop. This is the crop recommendation. So the back end, that is the machine learning algorithm which we have to apply today in this session. So this is the crop recommendation. So when you just click on it, it will tell you, it will ask you the inputs, that is the features which you have to tell. And based on that input, it will tell you which type of crop that is recommended in your area, which type of crop you can grow in your farms that would be suitable for the farmers. So that is the crop recommendation. And second is the fertilizer. So it will recommend you on the type of which type of fertilizer should be the best suited for that particular soil which you are having in your farm and for the recommended crop. So again, this is the second thing. And third is the crop disease. So if you are having the picture, if you just send the picture of your crop and just click the picture and just upload it, it will predict whether there would be any disease that is have to be done by the crop, or whether there is no disease to the crop, and what precautions you should need, and what should be the symptoms. Everything is taken by these services, crop disease. So these three services have been made. I'll show you on this website, but the working which we have to do, because the backend again is the machine learning algorithm. On the basis of that, we are providing the recommendation. So that we have done. So let's click on the first, that is the crop recommendation. So see over here, there is one form. So you can see the form over here, and it is asking you find out the most suitable crop that you have to grow in your farm. So the first thing, because you have to tell the inputs, that is the nitrogen, phosphorus, potassium, pH level of your soil, rainfalls in millimeter, and which states you are belonging to, and the city. And on the basis of that, it will predict what type of crop. This is just the front end, and on the back end, actually what we are doing, that we also have to do, we are applying the machine learning algorithm for the recommendation of crop. Let me just type it. Nitrogen, we can say 104, and phosphorus is 18, and then we'll take potassium 30. I'll show you the data set also. Let's say 6.7 rainfall, and let's Assam, and over here we can take Guwahati. All right, and let's just click on predict. So see the output, that you should grow coffee in your farm. So that is on the basis of the inputs, that is the fields or the columns or features which we have input in our model, and from the model you can predict what type of thing you can grow in your farm, right? That is the crop. So that is very good for the if we'll say, if you want to build the smart agriculture system, and if you want to build the agriculture system, right, smart agriculture, and you want to help the farmers that they don't have any idea about AI or ML, you can just build like this a small website, so that and a platform from which they can just click on the features and they can just get the output instead of that part. So this is the first thing which we have done, and there is another thing also, that is the fertilizer. So see over here, get informed advice on fertilizer. So which type of fertilizer we can grow based on the soil. So for nitrogen, we are putting 104, phosphorus 18, potassium 30, and the crop you want to grow, let's say coffee. So see, the nitrogen value of soil is very high and might give rise to weeds. So these are the suggestions which they have given. First is the manure, coffee grinds, and then plant nitrogen fixing plants, and third is the plant bringing manure crops, and fourth is the use mulch wet grass by growing crops. So these are the recommendation or the fertilizers which we can use. So adding manure, so everything which we have applied. So if you are having these kinds of configuration in your soil, these are the properties. On the basis of that, these are the suggestions. So that's the second thing. This is again with the help of the machine and the deep learning. So next is the disease. So over here you have to choose the image. You have to upload that image, and on the basis of that, it will predict, okay, whether there is any we can say disease or for that particular kind of the crop or not. Let me just try. So I don't think I have the image, so I'll not just try over this. But for this crop recommendation, you can see the features and the prediction one. So this is just the front end. Now we have to work on the back end. Okay, so I hope everyone got the project or the case study which we are going to today. So let's first understand the random forest algorithm which we have to do, and then we'll move to the practical part. Okay. Yes, I'll share the URL of this website also. I have sent the URL of this website. So now let's move first to the random forest. We'll understand how random forest works, and then we'll move to the practical part of that. That is, we have to perform crop recommendation. All right. Any queries till now? Okay. So there is no query. Let's move to the random forest part then. Oh, I guess there is one more question. Let me check. Okay, no problem, ma'am. So we are doing crop recommendation using random forest algorithm, and Shruti Vadva Khatri, director of the Hash Logic InfoSec, and today we are performing crop recommendation using random forest. All right. So see, first what we have to see, that is the random forest, and random forest is a learning method that operates by constructing multiple decision trees. So what is decision tree? That will also do in detail, don't worry. So in this, what we are doing, we are having a different multiple decision trees, and we have to operate on that. And the decision, the final decision which we have to make, that is based on the majority of the trees that is chosen by the random forest. So that is the random forest we have. That is, in random forest we have multiple decision trees, and the output of a multiple decision trees, which comes the majority. So the majority of the output which we get, then we can say, okay, this final decision is ours because of the majority. And then what is a decision tree, which we have with us? So decision tree is just a tree shape diagram that used to determine what should be the course of the action, that what you need to take the action. So each branch of the tree will represent a possible decision, what is the occurrence or the relation. So that is we can do with the help of the random forest. Like, so you can see one example. So there are many users which are using this random forest currently today in remote sensing also. So these you can already see that we are using random forest. These are the applications of the random forest. First is the remote sensing. So in the remote sensing, you can see the ETM devices. So that is, they are enhancing the thematical mapper that is used on the satellites and from which we can see far outside the human spectrum, so that we can look for at land masses and we can just acquire the images of the Earth's surfaces. So when we acquire that, then after that we are applying this random forest algorithm. And accuracy is very much higher and training time is very less. That's why we are going for remote sensing these algorithm. And second is the object detection and the multi-class object detection. So for example, this multi-class object detection is done using the random forest, and it will provide you better detection in complicated environment. So if you have to sort out different vehicles such as cars, buses in the traffic, and you have to measure what would be the speed, so you have to calculate the speed and you have to store it. So again, the algorithm behind it is the random forest algorithm. And the third application is that the Kinect. Kinect actually it's a game console, and what actually do, it will track your body movements and it will recreate it in the game. So this Kinect also, this uses the random forest algorithm as a part of the game, and that will console by tracking body movements and then recreating it in the game, right? So here is the visual how they can do it. So as you can see, so the first your user is performing a step, right? So it will mark the user based on the accuracy. So Kinect just register the movement of the user and it will create the game, it will check in the game as you can see on the screen. So but actually how actually this is performing with the help of the random forest. So as you can see over here, first, the training set we are providing to identify the body parts, because you have in the random forest classifier, and what you need to do, you need to provide the data set. You need to train your model. So for training the model, we are identifying the body parts, that this is your leg, this is your hand, this is your face, so this is your arm. So we are giving these kinds of input. And when we're applying the random forest classifier and when user is performing, it will identify the body parts when the user is dancing, right? And then it will score the game avatar based on the accuracy, how accurate your hand movement or your leg movement as with the game, right? As the person who is performing on the game. So that is again the application of the random forest which we can apply. So there are various applications on which this random forest is applying. So now why we are going for the random forest, right? So because see, there are so many applications and we are saying this random forest is a good one. So there are a lot of benefits for using this random forest algorithm. But one of the main advantages is that it reduces the risk of overfitting and required training time, right? Because training time is very less and the risk of overfitting is also reduced. Because additionally, it offers a very high level of accuracy. And random forest algorithm, they runs efficiently in large databases and produces high accurate predictions by just estimating the missing data. So these algorithms, these are the why we are going for it, because the advantages, because it reduces the risk of overfitting also, and it required training time also. Additionally, it offers a high level of accuracy, and these random forest algorithm runs efficiently in large databases, which I told you, and they will produce very high accurate predictions by estimating missing data. So that's how they are doing it, right? Now we'll see why we are doing it. We have seen that, but we have to see what is now actually we are talking about, that is the random forest. Now we have already seen that I told you random forest or random decision forest, you can call it any time. You can call any random forest or random decision forest. It's a method that operates by constructing multiple decision trees. So you can see in this slide also that we are having different multiple decision trees, and we have to operate on this multiple decision tree during the training phase. Okay, and you can see the output of first decision tree is the apple, and the output of the second decision tree is the mango, or we can say lemon, anything, and the output of the third decision tree is again the apple. So we are having only 3 decision tree at this moment, and when we'll combine, it comes under the random forest, because forest is a combination of all the decision trees, right? So these decision tree which we have calculated individually, they will come into the random forest, and random forest, what will do, it will count the majority, what is the more quantity of the fruit which we are having. So if we'll count from 3 decision tree, we are having 2 apples, and we are having only one lemon, right? Or we can say the mango. So over here, 2 apples you are having and 1 mango you are having. So the majority is this one, that is the apple. So we can say our final decision that the random forest will choose this one. So it is purely based on the majority of the trees that is chosen by the random forest as the final decision. So that's basically the random forest. And now the decision tree. So because we have to generate one decision tree for that. So decision tree is a tree shaped diagram that we are using to determine a course of action. And you can see this diagram also. Each branch of this tree represents a possible decision, occurrence, or a reaction, right? And as we can see over here, first in a basket, we are having many fruits. And first we have to take decision, we have to filter it out. So we have to check what is the more quantity, or we have to check whether it's an apple or whether it's on we can say this mango, right? So on the basis of that, what we are doing, we are having a basket full of fruits, and first the condition which we have given for this is that the diameter should be greater than equal to 3. So if the condition is true, diameter, so you can see the greater than equal to 3. For we are having 3 fruits over here, so that is the apple, cherry, and we can say mango. So because cherry is having the less diameter, so it will go into this basket because the condition is false. And when the condition is true, so because apple and mango diameter is greater than equal to 3, so it will come over here into this basket. Now last step, what you need to do, you should have a basket, individual basket having filtered fruits. It will not contain the mixture of fruits. Every basket should contain a filtered fruits. That is only one category. So now this category has already been sorted out, that is with the cherry. And now this basket contains 2 kinds of fruits, apple and we can say this mango. So again, we'll apply another condition, that on any condition you can apply. So over here we are applying is color is orange. So if they are saying yes, that is the condition is true, then now because orange is mangoes is orange, or we can say this is an orange or yellow, whatever you can say. And for the apple, it's not an orange of color, so it will go to the false statement and it will go to the false basket. So that's what we are getting it over here. And now you can see at the last we are having individual buckets. We are having individual buckets which containing individual fruit, not the mixture of fruits. So that is how decision tree works. So there are some important terms which you should know, which we are using in decision trees also, and which we are using in random forest also. So see, as we have already seen the types of the machine learning, that is supervised, unsupervised, and the reinforcement. So again, this comes under the category of the supervised machine learning algorithm. And in the supervised, we are having two categories, that is the classification and the regression. So the training data, so we can see this algorithm picks a pattern that maps the input to the output value and uses this pattern to predict the values in the future. So that's what we are doing over here. And that is the classification problem, not the regression one. We have already understood the difference between classification and the regression, right? So now first thing which we have to see is the entropy. So these are the important terms which we have to see. So first see will that what is entropy. Entropy is just the measure of the randomness, or we can say unpredictability, which we are having in the data set. So we'll take one example of it. As you can see, first we are having the initial data set, that is a mixture of fruit, apple and the orange, or whatever you can say, this mango we are having. And what we are doing, we are just splitting it. So what we need to do, because this is just a measure, we have to see in the bucket, in the initial data set, that is the randomness, because you have not calculated how many apples or how many mangoes you are having. You are just taking it in the random way, right? So if you are having data in the random way and you can't predict the data set, so that is you are having the high entropy. So in the initial data set, as you can see in the slides also, we are having high entropy. And the next thing which we do is that we have to decrease the entropy. We have to lower the entropy. And how we can do that? On the basis of the decision, on the basis of the decision which we have to take. So over here, we have taken the decision that we have to split into two parts. So here, the bucket is divided into two parts, and you can see. So now over here, randomness is there, that there is only one mango in first basket and one apple in the second basket. But randomness, if we'll see, the first initial data set is less than the first one, right? So now in this case, we can say the entropy is the lower one. So at the initial data set, it was high entropy, and at the bottom, we can say it's the low entropy. So entropy is just the measure of the randomness or unpredictability which we are having in the data set, right? And the second is the information gain. So see, what is the information gain? It is just the measure of the decrease which we are having in the entropy when we have split the data set in is the information gain which we are calling. So in the example, we have taken high entropy in the initial data set, and then we are having low entropy in the second data set. As you can see, set 1 and the set 2. So E1 is the high entropy at the initial data set, and when we split it, when the decision is made, so it divided into the lower entropy, right? And E2 is entropy. So information gain is the difference of the both. So how much decrease we have come into the entropy, that is the information gain, right? So I hope this is clear to everyone. I'll take the questions and after completing the slides. So now see decision tree. In this, we have to see the leaf node also. So leaf node is a node that carries the classification or the decision. So that is, we are calling it as a leaf node. That is the end, which you are calling, which is not having any more child. So that is the decision. All are the apples over here, and all are the we can say the mango, and over here all are the one is there, and that is only the mango, and this is the apple. So these are the leaf nodes which we are having the decision. So that carries your main result, that is the classification, or we can say the decision. So these are the leaf nodes. And the last thing is that what are the decision nodes in our tree? So decision node is that node we are calling it as a decision node which contain two or more branches. So the first root node and the second you can see which contain two or more branches, that is our decision node. Okay, and the last one is the root node, right? So the root node which we are talking is the topmost decision node, which is where you have all of your data, right? So that we are calling it as a root node. So you can see the initial data set. So now we have looked all the various important terms so that we can better understand the random forest algorithm, right? So now we'll see the case study of the random forest. Yes. So as we have already seen, what we have done that we want to classify the different types of fruits which we are having in a bowl, and based on the various features. But that bowl is cluttered with a lot of options. So you have to create a training data set that will contain the information about the fruit, which includes the color, diameter, specific labels, and the fruits you are having apple, grapes, etc. So you would then need to split the data by sorting out the smallest pieces so that you can split it into the biggest way possible. So you might want to start by splitting your fruits by the diameter and then by the color. So you just want to keep splitting until the particular node no longer needs it. And that way you can predict a specific fruit with 100% accuracy. So that would be the thing which we can do over here, right? And as you can see over here, so this is the first decision tree which we are making it. And on the basis of the first decision tree that we have already seen, we are having a bucket. And on the basis of the bucket which we are having, so we are taking the decision, we are taking the condition, that is the diameter is greater than equal to 3. So that's what we have taken, and the condition of the true or false over here. Condition over the condition true or false. So first we have the in the false bucket, so we have categorized it, that is we have classified this fruit, and but still we are having a fruit that is a need to be classified, and then we have applied the another condition so that we can get the classified fruit, that's we get at the end, right? So this would be the tree 1, that is the first decision tree, because decision can be anything, that can be taken by anything. So that is the another decision tree, that is you can see in the random forest. So first condition which we have taken is that the color should be the red, right? Its color is red. Then we have bucket which contains apple and cherry, and the condition falls for orange or for mango, that is in the another basket. Then we are saying is the shape is circle. So circle is for cherry, and for apple it's false. So we have again categorized it. So see, the condition can be different, which can be applied to these kinds of decision tree. And this is the again the third decision tree. Now over here, the diameter equal to 1. So that is condition true and false that we are giving. And if it is grows in summer, again condition is false, right? Condition we are providing another condition. So see, on the different conditions or different things you are providing on the different decision trees, but the output is the same, that we have classified 3 fruits in the 3 buckets. So that was our goal, that was our aim that we have to do. And these decision trees we have to combine in the random forest. Okay, let me see whether there is a one query. Okay. Yes, random forest is used for classification also, and feature extraction. I'll show you the example when we'll do the practical. We'll show use for the classification purpose also. So I'll give you the example in practical. And yes, when we use random forest, okay. Sir, I'll show you both the random forest and I'll show you. So see, decision tree is the one, that is only the one decision tree. And if you use the random forest, that is the combination of the decision tree, right? I'll show you both decision tree and the random forest, and you can see how accurate your which model is performing. And both are used for classification. So we'll do this part in practical, decision tree and the random forest, and we'll see the accuracy. Then you can judge that which algorithm is working better. All right, sir. So we'll proceed further then. So over here, so as you can see, we are having 3 decision trees over here. And these were the decision trees, and if we'll take, so how does a random forest work? So for this, let's try to classify this fruit. So there is a one fruit which comes, and what you need to do, you need to classify which categories it belongs to, right? So you have to tell whether it's an apple, whether it's an mango, or whether it's in cherry, right? So what you need to do, so tree 1 will classify it's an orange, so on the basis of the decision tree which we have already made, so this say it's an orange, okay. And the second tree, it will classify it's a cherry, and the third tree will say it's an orange. All right, so these are the output which we get from the different decision trees. And the majority, so you can see first said it's an orange, second said it's a cherry, and the third said it's an orange. And how they have decided on the base of the condition, as you can see this tree 1, see the diameter, it will see the color, and if the condition that is grown in summer, and the shape is circle. So everything they have decided on the basis of that, it will say, okay, this is an orange. And if we go to the second one, it might get confused, and it will say, okay, this is the, on the basis of the same condition, it's the cherry one. And the third will also say it's a orange one. And now in the output, the majority, because majority of the decision tree, it say it's an orange. So random forest will go with the orange because majority have got it, right? So the fruit is classified as an orange. So that is how the classification is performing over here, right? So that's just the part. Now we'll move to the practical part, and we'll see the data set which we are going to take. And even if you want to work, because for this, I have shown you the crop recommendation. That is the project, small project which we are doing. It's a big project, but the small part which we are taking for this session, right? So should we proceed to the practical part now? Yes, any doubts, or should we proceed to the practical part?
It is clear, ma'am. We can go for practicals.
Okay, okay, great. So again, I am using Anaconda. Okay, let me share first data set with you. So this is a crop recommendation data set, and again, it's available on the Kaggle. And if it is not available, later I'll email you. All right, you can just download it, and you can quickly download it from here. I'll just send the data. This is the link for the data set. You can just download the data set if you want to start work with me. Okay, let's move forward. Let's create one new Python 3 notebook. I'll enhance its size also. Okay, is it visible? Is it fine now? Should I increase it?
No, ma'am. It's not clear, ma'am.
Not clear? All right.
Now it's fine. Little bit, ma'am. Little bit.
Okay, I'll increase more then. It's fine now?
Yes, ma'am.
All right. There is one query. Okay. First, let's rename it. And we'll give okay. So we have done. So now we'll import the basic libraries which we require. So let's import it. Again, NumPy, Pandas, Matplotlib. So we have seen the installation also. So these are the libraries, the basic one. Let's run it. Wait for this. Because it's a star over here. Yeah, now it's one, so it has been executed. Okay, so we'll write another query. So we'll write another query that is now the another things which we require. So the next thing is that we have to import another libraries from sklearn. Again, the machine learning library. So from it, we require the matrix. And over here, you have to import classification report. You will see everything in the classification report that we have shown in the previous lecture. That is your precision, recall, everything. And from sklearn, import matrix also. And then from sklearn, import tree also. Alright, execute it. These are the libraries which we require. I'll show it again. You can just write it. Done. So now the second step which we need to do is that we have to import the data set. So now let's import the data set. So because this is a CSV file, I'll show you the data set also. Crop recommendation. Let me go to this part. Now you can see, I'll increase the font of this also. Yes. Now you can see the data fields which we are having: nitrogen, phosphorus, potassium, temperature, humidity, pH value of soil, and the rainfall. That's the thing which we have given in our website also for getting the input, and that's what we are having. So yes, these are the inputs and context we are having. Yes. So let's now download it. As you can see, we are having this archive. Let's show in folder and we'll extract it. I'm using 7-zip software for extracting it, and it's a good one if you want to try. And archive 11. So see, this is the data set, crop recommendation. So see, this is the data set. You are having nitrogen, you are having phosphorus, potassium, temperature, humidity, pH, rainfall, and this is the label because you are using supervised machine learning classification. So on the basis of this, we can say this is a rice. On the basis of these parameters, we can say rice. So you can see how many options we are having for rice data, then maize, then chickpea, kidney beans, pigeon peas, moth beans, mug beans. So we are having almost, we'll see the data set first, how many rows we are having for the data set. So it's a huge, it's a quite good data, 2,201, 20, not 1, 2,200, we are having the data set, 2,200. So this is the data set which we are having. Okay. So what you need to do again, you need to import the data set. So over here, I'm already having, let me just find it raw. You can see the crop recommendation.csv. So I'm already having the data set into my Jupyter this folder. So I'll not upload it. So I have already shown how you can upload it just by clicking on the upload button and just selecting the file and then upload. That's how you will do. Okay. So let's do that because I've already uploaded. So let me just write the name of the file. I'll just write raw underscore recommendation. All right, let's execute it. See, it's done. So we'll see whether it's done or not with the help of the head command. So you can see the output. So see, nitrogen, phosphorus, potassium, temperature, humidity, pH, rainfall level. So these are the things which we are having. Okay. So now we have uploaded the data into the data frame. There is one more function that is a tail if you want to see the last 5 values. Execute it and you can see the output. So see, this is because the index has started from 0 and it was to 2200, so that's why the last it's taken 199 because index is started from 0. All right. So this is the tail. We'll see if you want to check how many rows and how many columns. So that is the shape. It is EDA. We are performing EDA, exploratory data analysis. 2200 rows and the 8 columns which we are having. All right. So I want to see what are the columns which we are having. Let's see the columns. These are the name of the columns. NPK, temperature, humidity, pH, these are this one. Now I want to see what are the things that is the label which we are having. So we are using label that I want to see unique, but different categories we are having for the crop. So let's see. We have to give the name of the column that is the label. And then we can use this unique function so that we can see the categories. So see, these are the categories: rice, maize, chickpea, kidney beans, pigeon peas, mug bean, black gram, lentil, pomegranate, banana, mango, grapes, watermelon, muskmelon, apple, orange, papaya, coconut, cotton, jute, coffee. So these are the categories which we are having in the data set. Might be there is one question. Okay, there is nothing. Let me close it. Okay, come to this part. Now let's move further. So we have seen our data set. We'll see its data type because we have to perform on it. We'll see the data types also. See, these are NPK are integer one, temperature, and these are the float, and the label, it's an object. Okay, that's fine. So we'll count how many values we are having for the label. For each category. So you can see this data set is very good because we are having 100 category of each. So this is a balanced data. Otherwise you will have the imbalanced data, so that would be very difficult for you. So now over here we can see the data is very balanced because we are having 100 values for each category, right? So now data is fine that we have seen. So now quickly let's take the features. So I told you in machine learning algorithm there are two things. First is the feature and the second is the target, right? So the feature is that the inputs that is you have to give to your project or to your user, right, or to your model, and on the basis of that it will predict what would be the output. So first we'll take the features. Let's take, so for that I need the columns name. So let me just do df.head quickly. Okay, NPK, temperature, humidity, pH and rainfall. So this till rainfall should be my features, and this label it should be the output. So that should be the target. So let me just write only these in the features. Let me take one feature variable on the data frame in the column name. Done. Like this. Let's execute. Yes, it's done. You can just type the features to check. Now you can see in the features there is another data frame, but it's in rainfall. It does not include your target or your label. And now what we need to do, we have to create a target also. So the feature we have created, but now so for now we'll say the target and we'll pass the label, right? So only this column we have to give in the target. That is the output which we want to predict. So now over here you can see target we have taken. Let's check target.head. So only this value, this column which we require, that is the label one. And 0, 1, 2, 3, these are the indexes. Alright, so now let's take one more column as labels. And again we'll define it in, we get the value from label. We'll take one account, empty, list, and model also. Execute it. Done. So now the time for doing the splitting, training and the testing part. So let's start that. So for that, we require first the libraries. So from sklearn model selection, you have to import train test script executed, done. Now xtrain, ytrain, the values which we have to take. So we'll take xtrain, xtest, ytrain, and ytest. So now over here we are applying this function. So tell me what should be the parameters which I have to pass. You can type in the chat box. Tell me what are the parameters which I have to pass. Xtrain will not pass. Xtrain and ytrain are not the parameters, that's the value which we are getting. But we have not declared what is the x and what is the y, how we can take that. Where we have stored the input and the output value, that we have to take. So in this session, I have stored it in the different. Yes. So in this, I have stored it in the different variable. You have to tell me that variable. Tell me that. Anyone? Okay, I'll show the code. Over here, I have to pass the parameter, but see, I have not declared x and y. Now tell me. Okay. Okay. I can't share the whole code in the chat box. Okay, I'll share the files and the data set on this email ID. You can just, I'll give it to ma'am also. You can get it from there. Or otherwise, you can just send a mail to me because I will not remember after this. So you can just write an email to me and I'll send you after these sessions. All right. And my email ID is shrutivadma99@gmail.com. And you will get it from ma'am also, from Shanu ma'am. I'll send it to ma'am. Okay. So now tell me what are the things which we have to do. Yes, tell me. Okay, no answer. Should I continue? Yes, any student wants to answer? DF? No, it's not the connected one because we can't take the whole data frame. We have to categorize it, no? That we have already done. Any other? Okay, I'll show the code. Okay, okay. I gave you hint also now. Okay, I'll ask last time and then I'll continue. Yes, my question was that what are the parameters which we have to take into this train and test bit function? Okay, if you're not getting, no problem, I'll continue. So see the feature. So instead of x, I use the variable features over here into which I'm having my inputs, not the output. And for the output, that is for the y value, I have used the variable with the name of the target, right? So that is x and y for this. You have said x and y, that is yes, that is fine, but I have not used the terms x and y over here. I have used features and target over here. So that's the thing which I need to write. So features and target. And then you have to give the test size also, that you forgot. Test size, that is again I'm taking 0.2 because it's the best way. If you take the test size, that is your training part will go to the 80% or testing will go to the 20. 75 and 25 is also fine, 70 30, but not less than this. And then the random string. Okay, let's execute this. It's done. So now we are having extrain data into the features will already go. And for the X test, also the features for the Y train target, for the Y test again target. Let's check the value. Extreme. First we'll check the shape. How many values we are having. So see, 7 columns, total was 8, but now we are having 7 because one label has gone to the target one. And 2200 was the rows, and for the training we are having 1760. So if you want to see the data, so X test dot head, so that you can see only the 5 values. Yes, these are the 5 values you can see. And this is randomly, that's why the index number is like this. So same, let's take for Y train. Okay, Y is capital. So 1670. These are the rows. And one is column, that's why it is showing comma. So 1670 is over here. And 1760. There is something wrong over here. Yeah, because we have given this size. And by test, we'll check. Okay, yeah. So it is fine. That's the 440 because that would be 22. Yeah, that is fine. That is the 440 thing because 1760 is for the x, right? And now first we'll try to perform on the decision tree so that you can see the difference. So from sklearn tree, we have to import decision tree classifier. We'll run this. Done. So now let's take one variable decision tree. And then we have to call this classifier. And then over here we have to give criteria. And I have shown you entropy. Yes, randomness that I have shown you. And then we'll take the random state. And over here you have to tell the maximum depth. That what should be the maximum depth of a tree. And it should be equal to 5. You can change this value also, and you can just do hit and trial method for doing this. Run. And this is done now. So now we have to provide the training. So for providing the training, we have to perform the fit function. So let's do this and onto this variable. For providing the training, we can use this fit function. For testing it, we can use the another, that is the predict. Yes, that is fine. And then we'll run it. So you can see the criteria, randomness, we have told it over here. And now we have to predict the values. Predicted values. Decision tree dot predict. And you have to pass the question paper, and question paper is in the X test. Right? Executed. Okay, decision tree. Okay, I have made the spelling mistake. I again will run it. It's done. Now we can see the predicted values. Okay. Yes. So now, because this is an array which has created, not the data frame. So now you can see these are the predicted values which they have predicted. We can see the y test value. These are the y test value. So now we have seen y test and the predicted. So we have to check how many values they have filled correctly, right? So that is the accuracy we have to see. So it's in the matrix, and that is the function accuracy score. And over here we'll pass first y test, and then we'll pass predicted values. We'll run this. And the accuracy score, it's in X now. We'll see the value of X. And you can see it's 0.9, that is 90%. Let me show you, let me print the percentage also to you. So you can see it's 90, right? It's 90%. So now you have seen for the decision tree, that is one decision tree they have created. Now let's do for the random forest. So we'll import first library of random forest. You have to import random forest classifier. Run it. Done. Then we'll take one variable. Call this function. And you have to take the estimators. Number of estimators, number of decision trees. Alright, let's execute it. Done. Now we'll train the model again with the help of the fit function. And it's X train and Y train. Done. And then we have to predict it. the accuracy score. So first the answer sheet, that is the Y test, and the answer sheet by student. This is the corrected one, by test, and the answer by students are by model, so that is predicted one. Let's run it. Done. Let's execute it. And now you can see the accuracy is 99%. So now you can see the difference between the random forest and the decision tree. Over there we are having one decision tree, and over here we are having 20, so as we have given. So we can see how much accuracy has been changed. Right? Let's print its accuracy. Okay, I have not put the comma. Yes. Now you can see the accuracy also, right? So now we'll do one thing, that is, you can see the random forest is the better one. So now we'll give another data set, and on the basis of that, we want to predict what the crop is. That is our model, that is the recommendation which we want to give. Now from here we know the random forest is working fine. So let's take one data set. So for that, I'll create one list. Before starting it, let me just see what are the columns which we are having, so that we can take the value in the list according to that. So we are having nitrogen, phosphorus, potassium, temperature, humidity. Okay, let me take one by one. So we'll create one variable with the name data, and let's create a array first, numpy. Let's create numpy array from this. Alright. And into this, we'll take first nitrogen, that is 104, which we already checked. And 18 would be the nitrogen 104, phosphorus, then potassium should be 30, and then 23.60, then 60.3, then we can take 6.7, and then we can take 140.91. Right, so these are the features, the data. So we are having nitrogen, phosphorus, temperature is 23.60, and humidity we have taken 60.3, pH we have taken 6.7, rainfall we have taken 140.9. Right, so this is our data, that is the input. Let's run it. Data we have taken. So for this, let me just print the data first. So this is my data, right? And now let's predict it. Prediction. And we have to apply the random forest, that is the variable for the random forest RF. And we have to predict, so predict function. What would be the input? So these are the input, and you have to predict on the basis of this. Let's run it. So it's done. So now we have to print prediction. See which crop it's telling. And it's coffee, which we have seen in our website also. So see, it's predicting it's coffee, and random forest is 99% is correct accuracy. So we have predicted according to this. So if you want to take one more test for this, so let's take a different value. So let me just copy the data and we'll make changes into this. And let me just change the values. Let's take this one. Done. Now again we'll do the prediction. And then we'll take parameter as data. Done. Now we'll print the prediction. And we'll see it's a jute. So this configuration we are saying for the jute. So now you can see what values we are taking it for that. Okay. Yes. Not except rainfall. That rainfall, so we have to take only the label we have not taken. Okay, I'll show first lines of code you want to see if. Okay, you can type any other questions which you are having also. So I'll show you the code.
Ma'am, good morning, ma'am. A small query, ma'am.
Yes, ma'am.
Ma'am, can we take we have been taken the variables like X train, Y train like that. Instead of X train, we can take our own variables, any other names, ma'am?
Yes, sir. Yes. That's why in previous session we have started with XY, and in this session we have taken features and target.
Okay, ma'am. Thank you, ma'am.
Okay. I'll share this notebook. Don't worry, ma'am. I'll share this code and the data set, everything, the slides. I'll share everything now. Any other query? I'll show you the code first. And see behind this, this is the website, and behind it, the backend, that is the machine learning algorithm. This is the one which we are using. So you can see, and this again, this website is in Python with the help of the Django framework. So if you're having any, if you're getting any problems in the code, you can just see the code. I'll share the code with you. And again, if you're having any doubt, you can just write an email to me, right? All right. Any doubt, any questions? Any query? Okay, great. Okay, so if there is a no query, then we'll meet at 11:30 for the next session, that is on intrusion detection. Okay, that's great, sir. During break, you can practice, and at 11:30, we'll start with intrusion detection. Okay, I will, sir.
Okay, participants, see you after a break. Yes, I have already announced about that. So quiz is scheduled in last session. I hope you people have scheduled with you. So after lunch break, you will be having a quiz. So be ready. So it will take just 15 to 20 minutes. So all should be ready with your laptop or desktop to attempt the quiz. It is mandatory. All the faculty members are requested to attempt it. Otherwise, you won't get the certificate. So I will share the link at 3 p.m. sharp. 3 p.m. 3 p.m. But the link will be open till 4. You can submit your response once. So in case if somebody joins little bit late, so the local coordinator can share the link, right? So you can get it finished by 4 p.m. and after that the link will be deactivated. Is it clear to all the remote center local coordinators? As per the schedule, the quiz link will be activated at 3 p.m. I will keep it open till 4. Hardly it will take 10 to 15 minutes. So spare some time and attempt the quiz. So your local coordinator will be having the link, or I will share it in the chat window, right? So see you all for our next session at 11:30.